Hello and welcome to my talk, Adafruit Circuit Playground Express as an on-air light for PyOhio 2023. My name is Nick. I am a professional and unprofessional Pythonista. I have a website with a blog. I have a GitHub profile with some code. I have a Mastodon account where I occasionally post something interesting. I have an email address you can use to get in touch. And I may be available for hire. This is our project for today. We're going to be building this thing, not the one at the top, the one on the bottom, and it's going to be a customizable, affordable, on-air light. The reason I built this thing initially is because my desk used to be in the living room, close to the kitchen. And so sometimes my wife would walk through the hallway, go get a glass of water. And then sometimes she would also want to say hi because she's fond of me. And rather than making her always ask, is now a good time, is now a good time, I figured if I put a little light on there, she can just figure that out. Great. The platform we have to work with today is Circuit Playground Express, which is a small device you may already have if you went to PyCon 2019, macOS, which is what I use, and Zoom, which is what my employer has used. The hardware involved is the aforementioned Circuit Playground Express, a long USB cable so you can reach across my wide desk, and optionally, I got a plastic enclosure to prevent the device from getting too much animal fur or dust or what have you. The software stack is even simpler. It involves really just a bit of Python, all in the standard library, and LaunchD, which comes installed on macOS and allows us to control background tasks. The components of the software are fourfold. The first one is a status file, which is a file that's going to contain a 0 if there's no call, and a 1 if there is an active call. There is an LED changer script, which will change the colors of the LEDs on the device based on the status file. There's a call detection script, which will be running on your machine, figuring out if there's an active call and making changes to the status file. And finally, a LaunchD service, which will ensure that the call detection script is running continuously. Starting with the status file, it needs to live on the device, so it will be in /volumes/circuitpy. We'll call it state, and we'll just put a 0 in there for now. Moving on to the LED changer script, it also needs to live on the device, and it should be called code.py because that is the file that will automatically get run when the device is actually powered. In the script, we will import the CPX module from the included library, which allows us to interact with the hardware. It allows us to work with all the inputs and outputs, specifically the LEDs, which we care about in this case. We will define a few colors in the tuple. We'll have a green and a red. We will set the brightness of the LEDs to 0.01, and if you've ever turned these on at this device without doing so, you will understand why. They're incredibly bright. And then we're going to write a small while loop that always continuously runs. Inside it, we will open the status file. We'll get the actual state. We will use the state to decide on the color, and then we will fill all the LEDs with said color. Simple enough. The call detection script should live on your machine. I have mine on this path. You can keep it somewhere else. If you have a repository to keep all the changes of the customized code, it's fine, wherever you'd like to keep it. It uses one module from the standard library, subprocess, and has only one function, detect. The function does start a little heavy, I admit. It uses subprocess.checkOutput to run a command called lsof, which is list of open files. It passes parameters I and then the value 4UDP, which returns a byte string so we can run the code on it and then split it on new lines to get essentially the rows of the output. The second line, gets all the rows of the output that are relevant to Zoom. It's just a list comprehension looking for the word Zoom somewhere in the row. After that, we want to gather the states. The current state of the machine is determined by those Zoom rows. If you have Zoom not running, you have 0 Zoom processes. If you have it running, you probably have 1. But if you have an active call, you will have 2 or more. Therefore, we check whether we have more than 1. And then the device state is just initialized to none here. We then open the state file and get the actual device state from it. If it is different from the current state, then we go and write the current state to the file. Since this is a script that we're going to run for testing, We also add if name of main, detect, and then we'll actually run the detect function. The last part is the launchd service. It needs to live in the path above, which is your home directory /library/launch agents. The naming convention for everything I found in there always looks something like com.vendorname.projectname.component.plist. So I named mine this. It starts off with some boilerplate XML. I wouldn't worry about that too much. It gets interesting where you define the actual properties of the service. So the first thing we define is its label, which is really just the name, aka the file name. The second thing we define is the command that actually gets run. The key is program arguments, and it is an array of strings of the different parts of the command separated by spaces. So in this case, we use a Python interpreter and we run the detect script. Use whichever Python interpreter you'd like and wherever you have your script here. The last part of it is a keep alive flag, which we set to true, which ensures that this service will continuously run over and over and over again, so that a script will get run and rerun and rerun. After this is all done, the only thing left is to run it. To interact with launchd services, you use a tool called launchctl, and the command is launchctl enable, and then the name of the plist file. And so if you've done all that correctly, and you have the device set up on your desk, you'll have something like this. Once it's running, if I go and start a Zoom call, it takes a few seconds, but you can see the green LEDs eventually turn to red, signifying that there is an active call. And then when I go and I end the call, it again takes a few seconds, but you will see that the red LEDs will eventually turn to green, and there is our no call state. Pretty nifty, huh? There's some considerations about this as it's currently built. There may be other ways to detect calls. You can detect camera and microphone use, for example. I found this to be a bit unreliable because I'm often on a call and I have both off. If it's a big town hall at a company, I might not have my camera because no one needs to see me eating lunch and no one needs to hear me speaking. So it's not super reliable. A manual switch would be kind of neat, huh? If you could just set it to red instead of having to start a whole Zoom call in the background for that. This talk is too short to cover that, but it is a useful thing to do. And I used a tool called xbar and a shell script to give me essentially a menu bar item where I could click it and then click a script name and it would just toggle it. So it would toggle from 0 to 1, whatever it was. And that allowed me to turn it from green to red manually. And it would then kind of just keep going from there as calls were coming and going. And the third thing is other statuses might be helpful. At some point I did implement a yellow, which meant I'm not on a call, but I'm trying to focus. And that was kind of different from I'm specifically on a call, definitely don't interrupt me. You may have other things you'd like to include in some way and then account for in the code. The future of this project for me is sort of funny because it's actually decommissioned. I have since moved into my wife's office down this hallway you saw initially. It has a door, and that's a really great signal for do I want to be interrupted or not. I guess I could hang it on a door. It might still be nice to have it as a should you knock kind of indicator, but then I'd have to figure out how to power it, and battery, I just don't need any more of that. I have 10 devices on my desk right now that need to be charged, and I don't need any more charge anxiety. The takeaways from this, I think, are what I'm really trying to convey here. And the main one is that I had no real hardware experience before I did any of this. I've been a web developer and just a software person forever, and I've never really interacted with anything that was physical and tangible, and it was really a ton of fun to do that. It also really wasn't very difficult, which leads me to believe that you can probably do this too, especially with something as simple as this Adafruit Circuit Playground Express device. Because devices like this that have a lot of inputs and outputs are just really fantastically fun toys. This is a useful project we built here, but when I received the device in 2019 at PyCon, I think on the last day before I left the conference in the hotel room, I wanted to play around with it a little bit. And so I wrote silly scripts and I made a bad theremin where I would use the light sensor and pipe the value of that to the speaker so I could shine a light on it and then move my hand up and down to get different beeps to show up. Silly, but fun. And a really interesting way of thinking about, honestly, different kind of stuff than software considerations usually have. And speaking of those software considerations, that's probably what most of us are doing. I think just statistically, we're all working on things that are really big projects and have revenue and are web scale and what have you. And I think it's important sometimes to just play. I think a lot of us got into this in the first place because we like tinkering with something, and it's sad to lose it completely. And so if it isn't the day job, maybe it can be a little fun on the side occasionally. And so I think we should all play more. And with that, I want to thank you for watching my talk. I hope you had a good time. The slides and code for this will be on my website, /talks. Shouldn't be hard to find. You can send me questions, comments, and job offers, as I mentioned, to either Discord, I'm at Nick Kantar, or you can hit me up on Fediverse or Mastodon, or you can shoot me an email. And the very last thing I want to do is, in 2019, I announced the first edition of PyBeach, which was a Python conference in Los Angeles. And it happened in early 2020, and then we all know what's happened since then. So I'd like to take this opportunity to again announce, hopefully, a return of PyBeach next year, probably late in the year. And if you're interested at all, I suggest you go to the website and sign up for the newsletter. It is extremely infrequent. And with that, thank you for your time, and have a great rest of your conference.